This string starts empty, but one symbol can double everything, another reverses it, and one deletes characters instantly. Can you predict the final answer before the code does? Want full solution? Check this video.
Hello everyone and welcome back. Today we are solving the leetcode problem, process string with special operation number 1. At first glance, this problem looks like a simulation problem. And fortunately, that is exactly what it is. So let's understand the problem. We start with, we are given a string S consisted of lowercase English letter and special characters like the star, the hash, and the percentage. We need to build a new string by processing S from left to right as follows. If the letter is a normal character, we just append it to the result. If we see star, we remove the last character if one exists in the result. If we see a hash, we duplicate the current result and append it to itself. And finally, if we see the percentage sign, we reverse the current string. Once we have processed every character, we return the final result. So let's walk through an example. Imagine that you have string S that looks like as A, P, hash, C, percentage. So first we will have an empty string result, and we will iterate over the string S from left to right. First, we read the letter A, it's a normal letter, so we append it to result. Then we read the letter P, and it's also a normal lowercase English letter, so we append it to the result. And then we read the hash. The hash, as we have said, we have to duplicate the current result, so the output will be ABAP. Then we read the character C. It's a normal character, so we append it to the result. And finally, we read the percentage. The percentage means that we need to reverse the current result. So the result now will be C, B, A, B, A. And this is the final answer. Now, let's think about the implementation. The easiest approach here is to maintain the string, to maintain a string, as I said, called result, empty string called result. And then we iterate over every character in the input string. For each character, we simply perform the corresponding operation. If it is a regular character, we append it to the result directly. And if it is a star, we pop back or remove the last character if it exists. And if it's hash, we append the string to itself. And finally, if it is a percentage sign, we reverse the string. That's literally the entire solution. So let's look at the code. First, let's define an empty string. Let's call it result. Then we will iterate over each character in the input string S, and if the character equal the character star, that means we need to remove last character. So in this case, we need to check if result dot size is the same meaning of if result is not empty. So in this case, we put back the last character. So result dot put back. Else, if the character equals the character hash, and that means duplicate the current result. So we will append the result to itself. So result plus equal result. And if our character equal the character percentage, and that means we need to reverse the current result. So we will call the STL API reverse, and we'll give it the result iterator again, and end. And finally, if it's none of these special characters, it's a normal lowercase character. So we just append it to the result. And finally, we return the result character. So let's run it and let's submit it. And as you can see, the solution is optimal. It beats 100% of all the solutions. In terms of complexity, if we say that n will be the length of the input string and each character is processed once, but keep in mind that adding and deleting from the end of a constant are a constant time operation. However, the duplicate operation and the reverse operation may touch every character currently inside the output string. Therefore, the overall complexity is proportional to amount of data that exists during processing. So the overall complexity will be 2 to the power n. And in terms of space complexity, it's O of the, let's say, X, where X is the final output size, since we are storing the resulting string. And that's it. A very clean simulation problem where the key is carefully implementing its special operation exactly as described. If this explanation helped you, don't forget to like the video and subscribe to the channel and hit the notification bell. Thanks for watching, and I'll see you in next one. Bye.